Okay, so let's dive in. Today we are going to be tackling the James Webb Space Telescope
Oh,
and
wow.
all those incredible color images that it sends back to Earth.
Yeah,
You've given us quite the reading list: YouTube videos, articles, even some Wikipedia.
yeah.
A real deep dive buffet.
You could say that, yeah, and it's no surprise there's so much interest in this project,
Yeah.
and for good reason.
Our mission to try and figure out just how those stunning visuals are created and why they matter.
Right.
You know, those images are actually made from black and white data, right?
Yeah.
It's like getting a jigsaw puzzle, but without the picture on the box.
That's a perfect analogy. It really highlights the role that scientists and image processors play
Right.
in bringing those hidden wonders of the universe to light.
So before we get into all that, let's start with the basics.
Okay.
Why is the James Webb Space Telescope, or JWST, such a big deal?
Well, JWST is the successor to the Hubble Space Telescope, but it's designed to see even farther back in time
Okay.
to the universe's earliest stars and galaxies.
Wow.
And that means capturing light that has been traveling for over 13 billion years.
Over 13 billion years.
Yeah.
That's older than the Earth itself. It really puts things in perspective, doesn't it?
It certainly does.
Yeah.
And to understand how JWST can see so far back, we need to talk about its infrared vision.
Okay.
Remember, it doesn't see the universe the same way our eyes do.
So it's not just a bigger, fancier telescope, it's actually detecting a different kind of light?
Exactly.
Wow.
JWST is designed to see in infrared light, which is invisible to us.
Okay.
Now, infrared light has longer wavelengths than the light we see,
Okay.
which means it can penetrate those clouds of dust and gas that would normally block our view.
Like having X-ray vision, but for space?
You could say that. And this ability is crucial because the early universe is filled with dust and gas.
Right.
Without infrared vision, we wouldn't be able to see those first stars and galaxies forming.
I remember reading about something called redshift in one of the articles you sent.
Yes.
How does that tie into all of this?
Great question. Redshift is a really important concept in astronomy.
Okay.
You know how the sound of a siren changes as it moves towards or away from you?
Yeah, like higher pitched coming towards you, then lower as it goes away.
Exactly.
Wow.
Well, light from distant galaxies gets stretched in the same way as the universe expands,
Oh.
shifting it towards the red end of the spectrum.
Okay.
That's how we know those galaxies are moving away from us, and it's also why JWST needs to see in infrared.
Gotcha.
That ancient light has been redshifted so much that it's no longer visible to our eyes.
So JWST is like a time machine, and it has special vision.
You got it. But all the data it collects is actually in black and white.
Oh, right.
So how do we get those amazing color images everyone loves?
Yeah, that part has always felt like magic to me.
It's a fascinating process, blending science and art.
Right.
Scientists start by using filters to capture specific wavelengths of infrared light.
Like putting different lenses on a camera.
Exactly. Each filter captures a different slice of the infrared spectrum, and then they assign different colors to those slices based on the wavelength.
So the colors aren't random, they tell us something about the light being detected.
Right. Typically, blue represents the shortest wavelengths and red the longest.
Oh, okay.
And this helps scientists understand the composition and temperature of what they're seeing.
That makes sense.
Yeah.
But those objects are billions of light years away.
Right.
The signals must be incredibly faint.
They are. So scientists use techniques like stretching and compressing the data to make those faint details visible without losing the bright details.
So they're revealing the hidden universe by fine-tuning the contrast, almost
Yeah.
like a cosmic photo editor.
That's a great way to think about it.
Wow.
And they also have to meticulously remove any artifacts or anomalies from the data.
Oh, right.
Anything that could distort the final image.
You can really see the dedication in the sources you provided.
Yes.
Dr. Clampin, the project scientist, spent 15 years on this project,
No.
starting from scratch and overcoming countless hurdles. That's the kind of commitment it takes to revolutionize our understanding of the universe.
Absolutely.
Right.
Dr. Clampin's story is inspiring, and it speaks to the human element behind all of this incredible technology.
It also shows how much thought goes into each image, from capturing the raw data to processing it and composing those stunning visuals.
Yeah,
There's a real artistry to it, wouldn't you say?
definitely.
Yeah.
Scientists use principles of photography, just like an artist would.
Hmm.
Composition, cropping, even deciding which way is up, since there is no up or down in space.
Wow.
Yeah.
It's fascinating how they balance presenting complex data with creating an image that captures the imagination.
Right.
Speaking of exploring, you provided some fascinating information about those two main cameras on JWST, NIRCam and MIRI.
Oh, yes.
Let's dive into what makes them so special.
Absolutely. In our cam, the near-infrared camera, and ERI, the mid-infrared instrument,
Okay.
are like having multiple sets of eyes on the universe.
Okay, I'm intrigued. Tell me more about these cameras.
So NIRCam and MIRI, right? Like having multiple sets of eyes on the universe.
Yeah, and you mentioned that they're like having multiple sets of eyes, each revealing unique details.
Yeah.
Tell me, what exactly is the difference between them?
Well, NIRCam, the near-infrared camera, captures light that's closer to the visible spectrum.
Hmm.
Think of it like getting a closer look at things,
Okay.
like star-forming regions, young stars, and even those incredibly distant galaxies.
So NIRCam is for those really hot, bright objects.
You got it. Now, NRI, the
Well,
mid-infrared instrument, detects longer wavelengths.
okay.
This allows it to see cooler objects,
Mm-hmm.
things like dust and gas clouds, planets forming around stars,
Okay.
and even the very earliest galaxies.
So it's like NIRCam gives us the close-up, and NRI lets us peer through the cosmic fog to see those fainter objects.
Exactly. And the really cool thing is that by combining data from both cameras,
Yeah.
we get a more complete picture of what we're observing.
Right.
For example, an IR-cam might capture the hot gas around a star, while MIRI sees the cooler dust and gas farther out, where planets might be forming.
It's like having two pieces of a puzzle that fit together to reveal a much bigger picture.
Right.
But how do they actually combine those different perspectives into a single image? That seems pretty tricky.
It's definitely complex, but the results are amazing.
Yeah.
Remember those filters we talked about?
Right.
Each camera has its own set, and scientists carefully select which ones to use from each camera
Okay.
based on what they want to highlight.
So it's like choosing the right spices to create a specific flavor.
It's a great way to put it.
Yeah.
And once they've chosen the filters,
Yeah.
they have to make sure the data from each camera is perfectly aligned.
Okay.
Since they're looking at the same object, but from slightly different angles.
Kind of like taking two pictures of the same thing with two different cameras and then trying to merge them seamlessly.
Exactly. And once they have everything lined up,
Okay.
they assign colors to each filtered image based on the wavelength of light, just like we talked about before. But when combining an ICAM and MIRI data,
Yeah.
they have to adjust the color palettes to make sure the final image is visually coherent.
It sounds like a lot of artistry and technical skill go into those final composite images.
There is.
Yeah.
And those choices, like which colors to use,
Yeah.
can really change how we see and interpret the data.
That makes sense.
Yeah.
So it's not just about capturing the data.
Right.
It's about presenting it in a way that tells a story.
Exactly. It's about revealing the universe's hidden beauty and complexity in a way that we can all understand and appreciate.
And speaking of the human element, the YouTube video you sent really highlighted the dedication of the entire JWST team.
Yes.
They had to overcome so many challenges to make this mission a reality.
It's true.
Yeah.
They pushed the boundaries of technology, from designing a telescope that could operate at extremely cold temperatures to figuring out how to fold this massive tennis court-sized sun shield
Right.
so it could fit inside a rocket.
That sun shield is amazing. I remember reading about those late-night freeway closures in Los Angeles when they were transporting it.
Yeah.
I can just imagine those calls to the California Highway Patrol.
Right.
Yeah, we need to close down a few lanes of the 405. We're moving a telescope the size of a tennis court to French Guiana.
It's mind-boggling, isn't it? And then think about that incredibly intricate deployment process
Yeah.
with 178 release mechanisms
Oh, wow.
that had to fire in perfect sequence to unfurl the sun shield once they were in space.
178 release mechanisms. That must have been nerve-wracking to watch.
Absolutely. But thankfully, everything went off without a hitch.
Yeah.
And what's even more remarkable is that JWST is actually exceeding its initial expectations
Oh, wow.
in terms of image quality, sensitivity, and even pointing accuracy.
So not only did they pull off this unbelievably complex mission,
Right.
but they managed to surpass their own goals.
Yeah,
That's incredible.
it really is.
Yeah.
And that enhanced performance is leading to some truly groundbreaking discoveries. Remember the sparkler image we talked about earlier?
Yeah.
The one with all those globular clusters around a distant galaxy?
Yeah, those clusters of stars that might be some of the oldest structures in the universe.
Right.
Wow.
That image is a perfect example of how JWST is helping us unlock the secrets of the early universe.
Okay.
And that's just the beginning.
Wow.
It's already made so many other discoveries,
Mm.
from detecting water plumes erupting from Saturn's moon Enceladus to studying the atmospheres of planets outside our solar system.
It makes you wonder, what else is out there waiting to be discovered? What mysteries will JWST unravel next?
It's an exciting time to be an astronomer, that's for sure.
Yeah.
JWST is not just a technological marvel.
Yeah.
It's a testament to the power of human collaboration and our relentless pursuit of knowledge.
I think that's what really resonates with me.
Yeah.
It's not just about the science.
Right.
It's about the spirit of exploration and pushing the boundaries of what we thought was possible.
I agree. And it shows how investing in space exploration isn't just about understanding the universe.
Right.
It also drives technological advancements that can benefit everyone.
Right, and it's not just about the practical applications, it's also about inspiring the next generation of scientists and engineers.
Yes.
I mean, if seeing those images of distant galaxies doesn't make you want to learn more about the universe, I don't know what will.
It's hard not to be awestruck by those images, isn't it?
Yeah.
They're a reminder of the vastness and beauty of the cosmos
Yeah.
and our place within it.
So we've talked about the technology, the science, the art,
Yeah.
and even the inspiration behind JWST.
Right.
But I want to bring this back to the listener.
Okay.
Why should someone who maybe doesn't know a lot about astronomy care about a telescope millions of miles away?
That's a great question. I think there are several reasons why JWST matters to all of us.
Okay.
First, it shows what we can achieve when we work together.
Mm.
This incredible project brought together the best minds from around the world. Scientists, engineers, technicians, and so many others,
Right.
all working towards a common goal.
It really highlights the power of international cooperation, especially when tackling these big scientific challenges.
Absolutely. And second, it's
Sure.
about expanding our understanding of the universe
Mm.
and our place within it.
Mm.
JWST is showing us things we've never seen before,
Okay.
helping us answer some of those fundamental questions about where we come from and how we got here.
It's about our origins, our history, our connection to something much larger than ourselves.
Exactly.
Hmm.
And finally,
Nice
it's
job.
about inspiration.
Yeah,
JWST reminds us that there's always more to learn and discover,
right.
that the universe is full of wonders,
Yeah.
and that the human spirit of exploration is alive and well.
It's a reminder that we're capable of incredible things, both scientifically and artistically.
Yeah,
I mean, those images aren't just data points,
right.
they're works of art.
Absolutely. They're both scientifically insightful and visually stunning. And they really show the power of blending science and art to communicate complex ideas.
Okay, we've covered a lot of ground in this deep dive,
Yeah.
but before we wrap up, there's
Uh-huh.
one more aspect I want to explore.
Yep.
We've talked about JWST's ability to see back over 13 billion years.
Right.
What does that actually mean?
Well, it means we're seeing those objects as they were 13 billion years ago,
Wow.
not as they are today.
Okay.
The light from those distant galaxies began its journey long before our sun and solar system even existed.
So we're literally looking back in time.
Yes, and that's what makes it so significant.
Right.
It's like having a time machine for the universe.
Wow.
We're witnessing the birth of galaxies, the very first stars igniting
Wow.
events that shape the cosmos as we know it.
It gives you chills just thinking about it, doesn't it?
It certainly does.
Yeah.
And it helps us understand how the universe evolved from a hot, dense soup of particles
Okay.
into the complex structures we see today.
And all of that is encoded in those stunning images from JWST.
Right. It's incredible.
It really is.
Yeah.
And I think that's a perfect segue into the final part of our deep dive,
Okay.
where we'll explore the significance of those images and what they tell us about the history of the universe.
Sounds good to me.
Oh,
Welcome back. We were talking about how JWST acts like a time machine, letting us see objects as they were billions of years ago.
exactly. And that's what makes these images so much more than just pretty pictures, right?
Right.
They're giving us clues about the universe's earliest history.
So looking at these images, we're not just seeing stars and galaxies.
Right.
We're seeing how they formed and evolved over billions of years.
That's right. It's like flipping through a cosmic photo album,
Oh.
starting from the very first snapshots after the Big Bang.
You mentioned that the universe started as this hot, dense soup of particles.
Yes.
How did we go from that to stars, galaxies, planets, and everything we see today? Well, that's what JWST is helping us figure out, right? It's allowing us to observe those early stages of galaxy formation, how those initial clouds of gas and dust coalesced into stars, and eventually grew into the majestic structures we see today.
It's amazing to think that those processes happening billions of years ago
Right.
shaped everything we see around us, the planets, the stars, even the atoms in our own bodies.
Absolutely. We're made of stardust, and JWST is letting us trace those cosmic origins back further than ever before.
Wow.
Remember that distant galaxy we talked about earlier?
Yeah.
The one with a redshift of 14.3?
The most distant galaxy ever observed.
That's the one.
Wow.
Observing galaxies like that so early in the universe's history
Right.
is crucial to understanding how the first galaxies formed and how they influenced the evolution of the universe as a whole.
It's mind-boggling to think that we can even see that far back in time, but it makes sense that JWST is making all these incredible discoveries.
Yeah.
It's not just powerful, it's also specifically designed to study these early epochs of the universe.
Right, and that's why its infrared vision is so crucial.
Right.
That light from the early universe has been stretched so much by the expansion of the universe
Yeah.
that it's shifted into the infrared part of the spectrum.
So JWST is perfectly equipped to capture those faint signals from the universe's distant past.
Yeah.
And it's already revealing so much, like that cosmic cliffs image.
Oh, yes.
The one with all the colorful clouds and those towering pillars of gas and dust.
Oh.
It's breathtaking.
That image is not only visually stunning,
Right.
it's also a treasure trove of scientific data.
Hmm.
It's showing us active star formation happening right before our eyes,
Wow.
or at least as it was happening millions of years ago.
And that data can help us understand the life cycle of stars.
Right.
How they're born, how they evolve, and how they eventually die.
Yes.
And speaking of life cycles, we talked about those water plumes erupting from Saturn's moon Enceladus.
Yeah.
What's so significant about that discovery?
Well, those plumes suggest that Enceladus has a subsurface ocean,
Oh, wow.
which means it could potentially harbor life.
What?
JWST is helping us to study the composition of those plumes, looking for any signs of organic molecules or other indicators
Okay.
that might point to the possibility of life beyond Earth.
Wow. So JWST isn't just looking back in time, it's
Yeah.
also helping us to search for life elsewhere in the universe.
Yeah,
It's mind-blowing to think about the scope of this mission.
it really is. And we haven't even scratched the surface of what JWST is capable of.
Mm.
The data it's collecting will keep astronomers busy for decades to come.
It feels like we're at the dawn of a new era of astronomical discovery.
Yeah.
And it's all thanks to the incredible ingenuity and dedication of
Truly.
people who made JWST a reality.
Absolutely. From the scientists who conceived of this mission decades ago,
Right?
to the engineers who designed and built this incredibly complex machine,
Yeah.
to the technicians who painstakingly assembled and tested every component. It's a testament to what humans can achieve when we work together towards a common goal.
It's inspiring, isn't it, to think that we're capable of building something so sophisticated that it can unravel the mysteries of the universe,
Yeah.
see back to the very beginning of time,
Right.
and maybe even help us find evidence of life beyond Earth.
It is, and it's a reminder that there's still so much out there that we don't know, so much left to discover.
And that's what makes it all so exciting, right? The unknown,
Yeah.
the possibility of new discoveries,
Right.
the constant reminder that we're part of something much bigger than ourselves.
Exactly. And I think that's a perfect note to end on.
Yeah.
As you continue exploring the images and discoveries from JWST,
Mhm.
remember the incredible journey behind each pixel, the science, the technology, the human spirit of exploration,
Right.
and let it inspire you to keep asking questions and seeking out new knowledge.
Well said. And thanks for joining us on this deep dive into the James Webb Space Telescope.